Given the graph of f of x equals x squared, shown here on the left, find the function rule based upon the graph of g of x, shown here on the right, where g of x is in the form of a times f of the quantity x minus c plus d. Recall, if g of x is a transformation of f of x, we can write g of x in the form of a times f of the product of b in the quantity x minus c plus d, but because of the form given, we know b equals 1. And f of the quantity x minus c is equal to the square of x minus c, which indicates g of x will be in the form of g of x equals a times the square of x minus c plus d. Recall where a indicates a vertical stretch or compression, c indicates a shift left or right, and d indicates a shift up or down. Sometimes we'll also see the form where c is replaced with h and d is replaced with k, because h comma k is the vertex. If we take a look at the graph of f of x and the graph of g of x and track the vertex, for f of x, the vertex is the point 0, comma 0. For g of x, the vertex is 3, comma 1. Notice the vertex has been shifted right 3 units and up 1 unit, which indicates c equals 3 and d equals 1. This indicates g of x must be in the form of g of x equals a times the square of x minus 3 plus 1. Again, we can see from the vertex form of a parabola, 3, comma 1 is the vertex. And now we'll talk about a couple ways to determine the value of a. We should recognize we have a vertical reflection as well as a vertical stretch, which indicates the absolute value of a is greater than 1 and a is negative because of the vertical reflection. One way to determine the value of a algebraically is to select any point except the vertex on g of x, perform substitution, and solve for a. For example, if we select this point here, which is the point 4, comma negative 1, which might be hard to see, we would substitute negative 1 for g of x and 4 for x. This gives us negative 1 equals a times the square of 4 minus 3 plus 1. Simplifying, 4 minus 3 is 1, the square of 1 is 1, a times 1 is a. We have negative 1 equals a plus 1. Subtracting 1 on both sides, we have a equals negative 2. Which means we now know that g of x is equal to negative 2 times the square of x minus 3 plus 1. Let's also discuss how we can determine the value of a by analyzing the graph of f of x and g of x. Looking at the function f of x, starting at the vertex, notice if x increases by 1, y, or the function value, increases by 1. But if we compare this to the transformed function g of x, notice if x increases by 1, the y value decreases by 2. And we have to multiply 1 by negative 2 to obtain negative 2, which is why a equals negative 2, which results in a vertical reflection as well as a vertical stretch by a factor of 2. I hope you found this helpful.